So from there. Okay, good. So the cars in Jamaica, they do a lot of bauxite mining. Jamaica don't have the energy nor the plant to process the bauxite so you could get the aluminum. Good. But the source of aluminum is bauxite. All right. So aluminum is there. Um, can you identify an element that our body use for strong bones and teeth? Do you know what that element is?
Calcium.
Calcium. I hear the symbol for it. Good. Right there. Now, which element does plants use to make protein? There's a particular element that plants use to make protein. Do you know what that is? Plants use it to make protein. Anybody knows? All right, nitrogen is the answer. Good. So plants use, so when you get proteins, a combination of nitrogen and the glucose. All right. Yes, that's what protein is. Now, next question though. You know about glucose, right? What are the elements that are used to make glucose? What the elements are? There are three elements that plants use to make glucose. Three elements. What? What? Brittany? Kadi?
Oh, sir. We don't know.
All right. Three elements that plants use to make glucose are carbon, hydrogen, and oxygen. Those three elements. So your protein then consists of four elements: carbon, hydrogen, oxygen, and nitrogen. Good. Now, so I just have this session just to let you know that don't see chemistry as a fictitious subject or the periodic table as something that people make up just so. No, it's based on something that's naturally existing, but we just name it, right? Based on its properties. All right. All right, I'll talk about properties. We talk about its nature, its characteristics, what it looks like, what it's able to do, etc. All right. All right. Now, when you 1 second here. Historical development of the periodic table. All right. 1 second. We're going to read something. You can take turns in reading it. And then we'll probably watch a video based on this history, which you need to know. All right. Can somebody read this one, please? Anybody?
In 1869, Russian chemist Dmitry Mendeleev started the development of the periodic table arranging chemical elements by atomic mass. He predicted the discovery of other elements unless spaces open in his periodic, can't pronounce the word, sir.
Periodic.
Periodic table for them. In 1886, French physicist Antoine, and I can't pronounce that the word, sir,
All
first
right.
discovered radioactivity.
Good.
So the word of it can make a cause bad word.
Well, you're right. And I wouldn't even bother trying to pronounce it myself. All right. All right. So basically, the periodic table was basically arranged by natural people like ourselves. And the principle that that gentleman had used to um, develop or to design the atomic table, or the periodic table rather, is the atomic mass. So obviously, they used to weigh these atoms. Good. And know that elements are made up of atoms. Cool. All right. Let me see now. All right. Could somebody read this one for me? Bradshaw, you can read this one, please. Mr.
How
Bradshaw.
was the periodic table developed and organized? The original table organized by the elements by increasing atomic weight. Each horizontal row on the periodic table is called a period. Elements belonging to one of the 18 groups will share similar properties. Atoms of
Properties.
each element within a group have the same number of electrons in their outermost
Most
element
shell.
electron shell.
Good. All right. So it's saying to us then, thank you. It's saying to us then that the how the periodic table is arranged. You have groups, you have period. Good. So they say that each horizontal row on the periodic table is called a period. And elements belonging to one of the 18 groups will share their similar properties. Atoms of each element within a group have the same number of electrons in the outermost electron shell. So I'm going to show you what they're referring to as well. All right. Now, so today we're going to focus more on the group and period, how to determine which group, which period an element belongs to. All right. So are we ready now? Are we ready now? Nobody answering? Not
Yes.
ready yet? Oh, yeah, no one there. All right, so we're going to make an atom, build an atom, then further explain to you how this works. All right. We're going to start off with the ones that you are actually aware of. So you have an atom. Now, this circular dotted line, as you're seeing, these are what they call shells. So it mentioned Atmos shell. That's what they call shell. All right. Now, inside an atom, the center of the atom actually is made up of, is actually called the nucleus. And that is made up of both protons and neutrons. So the nucleus is made up of both what? Protons and neutrons. Now, these, the classification given to protons, neutrons, and electrons is referred to as subatomic particles. So you can make note of that. So the atom is made up of, well, is so far, according to scientists, so far, you know, regularly people discover more and more things. Eh? So far, an atom particle is made up of 3 subatomic particles named protons, neutrons, and electrons. Got that? Got that? All right, so let us put on some electrons here. Now, let's see if I can put you in there. No, so this is hydrogen. If I may. No, this is actually hydrogen. Now, hydrogen only has 1 electron. And it only has 1 shell. Now, the number of electrons in the last shell is used to identify the group number of the atom, or the element rather. The number of shells that the atom has is used to identify the period. Good? So like hydrogen now, it is in period 1 because it only has 1 shell using up, which is this shell. But it is in group 1. Only 1 electron. Both of you understand that?
No,
Both of
sir,
you?
my last.
Last. All right. So we can find them. So watch this now. What we're saying is the number of shells equal number of shells of an atom or element equals period number then the number of electrons on the last shell of the atom slash element equal to group number. You have that? So you need to just know these two key information right here. So write that down. You have that? Finish writing? Wanna finish right now? Hello? Brittany Cadine, now hear me?
No, sir. Don't finish as yet. Almost.
Okay, all right. So your first assignment,
Finish.
finish. Okay, good. Your first assignment is to make models of the first 20 elements. All right. Now you're going to label them. You're going to identify the number of the atomic number is. You're going to also tell me the period number for them, and also the group number as well. All right. First 20 elements, the atomic.
So you said that's our assignment to do now?
No, man, your first assignment, so next class, next week, Monday, come prepared to present that. You can use cartridge paper. Be creative. Don't want to just draw one someone else put on the exponent. No, let's be creative. All right, be creative. Something it's like you're making a toy, something like that. All right, let's be creative. All right. So hydrogen then is in both period 1 and group 1. All right. Now let's add more electrons. Now this is don't focus on this negative thing as it. Don't focus on that. Now if you notice now that the name of the atom changes, how many electrons does helium have? How many
2.
electrons does 2? And which period is helium in? Which period is helium in? Based on the notes you got a while ago. Which period is it in? Any answer? Try it, you have to try it. How many shells does helium have?
2.
It have 1 shell, 2 electrons. 1 shell. So if it was a 1 shell, then the period number for helium is what? 1, right? Good?
Yes.
Yes.
Huh? I'm not hearing you.
I say yes, sir.
Good. And how many electrons it has in its large shell?
2.
Good. So which group is it in?
Repeat, sir.
Which group is it in? Which group is helium in? Group 1 or group 2?
Group 1.
No. That means you're not reading the notes. What did the notes say right there, sir? Read it some, please.
The number of electrons on the last shell of the atom slash element equals to.
Group number. So this is the only shell it has. So how many electrons does it have on the last shell? And it's the only shell. How many tab?
2,
2. So which group is it in then?
2.
2. Exactly. All right. Let's add another proton. That's lithium. So add another electron now. Now you realize what happens when I try to put the electron on the first shell? What happens when I try to put it there?
It dropped down to the last shell
Good. Why do you think it's dropping down?
because that shell is full.
Ah, very good. That shell is full. So the first shell can have a maximum of 2 electrons. Good. So the first shell can only have a maximum of 2 electrons. That's what the science discovers, right? Now, how many electrons does lithium have? How many electrons does lithium have?
3.
3. Good. Let's see if you're thinking now. Come on, have a think now. What is the period number of lithium?
The period number will be 2
2. Exactly. Why you said 2, Brittany?
because with this one we use up the 2 shell.
Good. Set up 2 shells. Excellent. Very good. So the next question then is now, what is the group number? What's the group number for lithium?
The group number will be 3.
3. You sure? Read this. Read the statement. Read the statement right here, so, and see if it's actually 3. And apply the statement to it.
It will be 1.
Good. So you see problem gonna have? You need to read and apply what you read to the situation. Make sense now, folks? And understand that now, right?
Yes.
Good. So you can't just write down something just so and don't use the information. You have to use the information. All right. Okay.
Yes, sir.
All right. Thank you very much. All right. So let's move on now. All right. Let's try another one now. Really. By the way, what was the group number you said it was again?
Group number was 1.
It was 1. Okay. Let's check it. Huh? All right. Kadeen, your turn. What is the period number of beryllium?
There's a period number of beryllium.
Beryllium. Yeah, man.
So you have 4 electrons here.
The period number of beryllium.
2.
Good. 2. So it is because it's using 2 electrons. Good. All right. What's the group number of beryllium?
1.
Did you read the statement right here? Read the statement.
Number of electrons on the last shell of the atom. So it should be 2.
Two. Good. So I want you to practice to read and apply.
So hold on, sir. So
Yes.
the shell is inside. That is the inner circle, the smaller one.
Both of them are shells. The circles are shells. Dotted circles are actually shells.
Yeah, but I'd like to get a better understanding where I don't get confused.
Yes.
So I'd call it inner circle shell on the outside.
Yeah,
Yes.
they are both shells. The circles here, this circle
Okay.
here, and
Yes.
this circle here, they are both called shells or orbits. Good. Just like when you join the planets and the orbits and all this stuff, we use a little line, circular line to show where they are. So it's a similar idea. So the dotted circle lines are used as shells. And the blue circles, of course, are electrons, orange one, protons, gray one, neutrons. So this has two shells, guys, two circles. So it's period 2. And then there are 2 electrons on the outer shell. So its group number is 2. Got that?
Okay, sir.
Good. Good. So we're going to move on from there now. So I'm looking for something more to go. No. Worksheets. All right, still continue from here. Let's see if I can make this 1, 2, 3. So we have carbon here. So 2, 6. Okay, which group is carbon in? Which group is carbon in? Which group is carbon in? Anybody?
4.
4. Okay, good. Right. All right, so we'll move on from there. So now. Say they'll give us an extra sheet. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I finish. So this lock in 6, 7, 2 more. So this is neon. All right. So which group is neon in?
8.
Group 8.
All right. In this case, it's actually group 2. It's a gas. All right. Okay. So this one is
Okay.
yeah. So this one is not necessarily a part of the rule itself. So it's actually in group 2. All right. So let's say we can get to some game. Ready for this game? So the game is about find the elements. So this one will be a bit difficult. Let's try this one. this one. Let's try another one. Let's find it. I was hoping it would have increased the number of shells, but that's not possible right here. Let me draw some for myself and see what you're going to tell. Ready now? It's okay. All right, so let me draw myself. So here we have the that's one. All right, so I'm going to use some X's instead of the circles then. So this has 2 here. Good. This element, which period this element in? Which period does this element belong to? Anybody? Which period does this element belong to? Hmm? Which period does this element belong to?
Period 3.
Period 3. Very good. What is the group number? Before we're going further, Kadeen, you know why she said period 3?
Sir,
You know why she said period 3?
year 3,
Yeah, why she said period 3?
there's 3 electronics.
No, that's not right. Brittany, tell them why I said 3.
Because there are 3 shells.
3 shells. So if you count the number of shells, Kadeen, and the number of shells you count is equal to the period number. You have that now? Understand that, Kadeen?
I didn't hear you, sir. What did you just say?
Yeah, you have to count the number. You're not to mute your mic, just unmute your mic. The number of shells. When you count the number of shells, whatever you get after counting the number of shells is equal to the period number. So when I ask you for what is the period number of the atom, you have to count the number of shells to tell me what it is. You got that?
Okay.
Good. What's the group number? What's the group number? What is the group number for it?
1.
1. Okay. All right, good. So you get that. All right. Let's draw some more. So we're gonna draw another shell. This time is your question, this is not coming. And question, why did I draw another shell and not use the third shell? The ideas? Why I think I draw another shell and did not use a third shell? Any ideas?
Because the third shell is full.
Well, because the third shell is full. So in other words, then, except the first shell. So the first shell must have a maximum of 2 electrons, and the other shells must have a maximum of 8 electrons. Good? Right. Now, Kadeen, what is the period number for this atom that I drew a while ago? What's the period number for this atom that I drew?
4.
4. Good. So you understand now. And what's the group number?
4.
4. Understand now. Good. So I understand that. Well done. All right. All right. So that's good. Very good. So we're going to a little research now. Just a little research. Now you're going to find out which of these scientists, when you can Google and find it out now, yes. Which of these scientists is responsible for these discoveries or contribution to chemistry? Which of these scientists are responsible for which of these discoveries or contribution to chemistry? So you can look them up and give me the answer.
Repeat, sir, about the assignment.
No, you're going to do it now, you know. You're going to look for these scientists, and you're going to tell me, you know, which of these discoveries match these scientists. For example, what did these scientists do? Did he discover that atoms are solid balls? Did he discover that the plum pudding model with negative electrons? Thomas, you understand? So let's look it up.
periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time: scandium, germanium, rhenium. The element he called Eka-manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitry predicted its existence, 30 years after he died. Dmitry died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitry Mendeleev, the architect of the periodic table, will be staring back.
An answer for anything, has it? Okay, Brittany. So, give me some answer. Who did what?
Dalton did the first one, atomic as solid
This one?
ball. Yes.
Okay. All right.
Thomas did the plum pudding.
Plum pudding. Okay. Wait, hold on. Kadina have any? Kadina have any?
No, sir.
Yes, sir. Yes, you're searching.
Yes, sir, I'm searching.
You must can find one. Hold on the I'm gonna make life easy for you. You must look for Rutherford. Okay, Kadeen? Kadeen,
Sir,
look for Rutherford. For what Rutherford did.
I'm not hearing you.
Look for what Rutherford did.
Rutherford did?
Yeah,
Okay.
what Rutherford did, yes. All right. Brittany, give me Shadwick. You found Shadwick, Brittany?
Yes, it is small positive nucleus.
Okay, so you discovered that there are small positive nucleus. All right, so let's see what he Kadeen Sir Rutherford did.
Nuclear structure of atoms.
Okay, structure of atoms. So which one is the answer then?
Nucleus contains protons and neutrons.
All right. So naturally we are saying that this one is this. All right, let's see if you all did a good research. So Shadrick says other way around. It's the other way around. See it? So Rutherford actually did small positive nucleus. He discovered that there are small positive nucleus. And actually it was mostly empty space. That was his discovery and probably conclusion. Shadrick now would have looked at the nucleus contains, discovered that nucleus contains protons and neutrons. That was the correction. So we can write this off as notes because the history, you need to know a bit about the history. All right. So you have the correct information at the top here. This one, these two were actually incorrect. When you finish writing, let me know, please.
Repeat, sir.
Write off the correct answers here and make the corrections here and have it down as notes. Yeah, you heard that?
Okay.
We gonna worship. Oh, say we gonna worship, yeah, yeah, yeah. We gonna worship. Sovereign God, you are the morning light. Everything that you do right. All power belongs to you, so you know we gotta worship you. My daily bread, the living word, the best name I've ever heard. Healing powers, they flow through you, so you know we gotta worship you.
We worship you. We worship you. Sovereign God, we wanna worship you.
you finish writing, let me know, all right? When you guys are finished writing, let me know. Thank you.
We praise you. We praise you.
Sovereign God, we want to praise you. Father God, you are El Shaddai, and we bow at your feet, Adonai. No one else come close to you, so you know we gotta magnify you. Your loving arms, they comfort me when the pressures of life fall on me. Thank you, God, for the things that you do, so you know we gotta worship you.
We worship you.
We worship you. Sovereign God, we wanna worship you.
We worship you.
We worship you. Mighty God, we wanna worship you.
We praise you.
We praise you. Awesome God, we wanna praise you.
We worship you.
We worship you. Mighty God, we wanna praise you. In everything we magnify Adonai. Lord, we lift your name on high. On high.
We worship you.
We worship you. Sovereign God, we wanna worship you.
We worship you.
We worship you. Mighty God, we wanna worship you.
We praise you.
We praise you. Awesome God, we wanna praise you.
We worship you.
We worship you. Mighty God, we wanna praise you.
Are you finished writing now? Almost finished writing?
Finish.
Finish.
All right, so that is it for tonight, because I don't have school tomorrow. All right, so remember now your first assignment is to make modules of the first 20 elements in the periodic table, and then you must come prepared to tell me the atomic numbers, the period number, group number, name of the element, and the symbol of the element. You can recall that? Can you recall that? Folks, can answer me, man.
Repeat, sir. Can we hear clearly? No. No.
I am saying, for your assignments, you need to give me make modules of the first 20 elements in the periodic table. Make modules of them. And then when you come, you'll do a presentation where you will tell me the period number, the group number, the atomic number, and the symbols for these 20 elements that you have created. All right? Heard that?
Yes, sir.
Okay, Brittany heard that as well?
Yes,
Good. All right, so what was your first class today? Who's gonna go first? What was your first class today?
Well, sir, at first, I didn't understand, sir.
Eh?
At first, I didn't understand anything.
Okay.
But as I go along, I
Mhm.
grasp and
Okay.
get understanding and technique of doing it.
Okay. All right. Okay, good. All right. What about you, Brittany?
it was okay.
It was okay for you. All right. Now, as you guys do the assignments given to you, things will improve for you. Now, this is just the easy part of the chemistry. But as you once you get the principles down and pat, then the section B of the syllabus will be much easier. All right. So don't worry yourself. Just do what you're asked to do. Okay.
So we must make modules of the first 20 elements.
Yes.
Their
Check.
name, number, and what
Period
else?
number, and group number. I am going to ask you those questions. But you must make the modules then. The first 20 elements. I don't want you to draw something or just also draw something. No. Be creative. You must can move the electrons with your hands. So where I'm going now?
Okay,
Yes,
sir.
sir.
Good. All right, so that's it. So have yourselves a good night and enjoy the rest of the week. All right.
Same to you, sir.
Thank you very much.
Thank you.
Thank you, Brittany. All right, later then.
Bye-bye.
All right, bye-bye.